So it asks us to solve the system, in this case with 3 variables and 3 equations. We want to go ahead and solve this following system. So the first thing we want to go ahead and do is do step number 1. So step 1, we want to go ahead and eliminate one of the variables. So eliminate one of the variables. So in this case, let's go ahead and try to eliminate, as we see, the negative 2z and the positive 2z here. So if we go ahead and try to eliminate those, what are we left with? Well, we are left with the following equations: the 3x plus a 4y, and that's now equal to a positive 14, and the 2x plus a y equal to that negative 9 there. So now that we have found our two other equations, we can go ahead and add them together, which will give us a 5x plus a 5y, and that is going to be equal to a positive 5 here. So we can now move on to step 2, and we need to eliminate from our other pairs, which are our bottom two there. So step 2, eliminate from, and we're going to go ahead and say the bottom pair. I will also star this equation here so that we can use it for reference later. So eliminating from the bottom here, what do we need to multiply the bottom in order to eliminate one of the variables? Well, we want to go ahead and try to be consistent here, so we can go ahead and eliminate those z's. What do we need to do? Well, we need to multiply by negative 2 in order to eliminate those z's there. So let's go ahead and multiply that bottom one by a negative 2. I'm going to go ahead and rewrite the one above it. Okay, and again, we're trying to eliminate those z's. So this will give us, in this case, a negative 2x, and then the negative 2 times the negative y will give me a positive 2y. And then finally, this negative 2 times the positive z gets us the negative 2z, and that's all going to be equal to a positive 18. So now what happens is our z's eliminate, and additionally it looks like our x's will eliminate. So let's add the result here. That will get us a positive 3y is equal to a positive 9. And it looks like we can just go ahead and solve for y here. So divide by 3, and you should get a y is equal to a positive 3 here. So what can we do with this positive 3? Well, using our start equation up here, we can go ahead and figure out what our x value is going to be. So let's go ahead and try to figure out what our x is going to be, and then finally our z value. So let's go ahead and take 5x plus 5y is equal to 5, and substitute in the fact that y is equal to 3. So that gets us a 5x plus a 5 times a 3, and that's going to go ahead and be equal to a positive 5. So if we go ahead and simplify just a little bit further, we are left with a 5x plus a 15 is equal to a 5. Let's subtract the 15, and we are left with a negative 10 equal to a positive 5x. So divide by the 5, and x is equal to a negative 2. So now we have y is equal to a 3, we have an x is equal to a negative 2. So now all we need to find is that z value. So we can go ahead, back up to the top, and pick one of these equations that we can plug it into. Let's go ahead and plug it into this first one here to figure out what our z value is going to be. So plugging this into our top equation there, we should get a 3 multiplied by, in this case, our x, which is a negative 2. Finally, plus a 4 times our y value, which is a 3, and then minus a 2 times that z, and that's going to be equal to that positive 14. So doing some simplification, we are left with a negative 6 plus a 12 minus 2z, and that's equal to a positive 14. And cleaning this up a little bit more, we are left with z should be equal to a value of a negative 4. So we now have z is equal to a negative 4. We have x is equal to negative 2, and we have y is equal to a positive 3. So we can go ahead and write our ordered triple here. Usually this will be in the order of x, y, and z. So we can do x and then our y and then finally our z value here.